Hi everybody, Steven here. Have you ever wondered what the difference is between NSX Multi-site and NSX Federation? Well, that's what this video is going to talk about. It's an NSX Multi-site versus Federation. Which one wins? Stick around. Thanks for sticking around. So why don't we jump into it? But before we do that, I always like to throw this out there. If this is stuff that you're interested in, please subscribe to the channel. It helps me out quite a bit. Without subscribers, there's no content developers. And I've actually run through some of the stats. It looks like 60% of the folks out there that watch this channel regularly are not subscribers. So just hit that subscribe button. It really helps me out. I'm trying to hit 1,000 subscribers or more. And for those of you that are already subscribed, hey, thanks very much. I appreciate it. So let's jump right into it. Okay, so let's talk about workload availability, or NSX Multi-site versus Federation. So a couple of things you got to keep in the back of your mind. This is also referred to disaster recovery with NSX. So there's a couple of different ways that we can provide for disaster recovery or availability of our workloads, right? A couple of things to keep in the back of your mind. My first bullet here is some of the deciding factors will be the latency between sites. Now, you're going to hear me talk about locations and sites and all that. This could also be like, the same data center, just, in different racks. So I'm going to use the word sites and locations very loosely here. But you could also apply this to racks of servers inside the same data center. Now, the big thing that's going to decide certain things, and I'll point those out, is the latency between your sites or racks or whatever, right? Is it less than 10 milliseconds, or is it basically all the way up to 150 milliseconds? So if you've got a fairly large distance away, again, these are the things that are going to decide what solution am I going to do or how am I going to architect this. There are a couple of different solutions that NSX has or VMware has for multi-locations. The first one is NSX Multi-site. That's been around for quite a long time. The advantage of that one, it's a small footprint, which you'll see. It's a single management plane, so technically you just have one NSX management cluster, so hence the small footprint. The single management plane, again, that could be a plus. That could be a minus as well. In other words, that could be an advantage or a disadvantage, depending on how you look at that. We support active standby solutions. You also hear references to simple disaster recovery. Now, a lot of this stuff I pulled out of the multi-site best practice guide. I'll leave links for that in the comments. But this simple DR refers to like an automated disaster recovery. Something happens, we recover. X amount of time goes by, we recover. That type of thing. We'll look at some of the requirements. With multi-site now, with NSX Multi-site, you do require a large maximum transmission unit size between the sites. The minimum that VMware wants is 1,700 bytes. If you got 9,000, rock and roll, okay? And the reason for this is because we have to have Geneve between the sites here. And again, before anybody starts thinking, what about encryption? Geneve doesn't provide for encryption. You have to have that on your own, okay? Whatever medium that you're connecting your sites with, okay? So we need that MTU size, that minimum MTU size of 1,700 between sites because we're going to be setting up Geneve tunnels between all the transport nodes on all the sites. So that could be considered as a disadvantage as well. Now, NSX Federation, the next half of this we'll talk about is NSX Federation. If you don't know what that is, you need to watch my Federation video. I'll walk you through that. I'm not going to go in depth in this one on it. I'll talk about some high-level stuff, but we're here to compare the two, so you kind of need to know that. So NSX Federation has a very large footprint, and you'll see that when I talk about it. If you've watched my video, you know exactly what I'm talking about. You need global managers, standby managers, local managers, so that can be a lot. The cool thing here is no requirement for a large MTU between sites. So I don't have to have that 1,700 byte MTU between sites. We could actually do fragmentation of the Geneve frame between sites. There's a thing called ART taps. And again, if you watched my video on that, you'll know what I'm talking about. Okay, so we don't have that, but we do recommend that you do have that MTU, but it's not a showstopper. This also requires an Enterprise Plus license, whereas the top one doesn't. There's other stuff that when comparing the two on solutions, typically most solutions are all supported with the NSX Multi-site, whereas Federation, there may be various limitations. I'll throw a chart up at the end of this video showing you that. So product positioning. Where do they both fit? So first of all, the sweet spot for NSX Multi-site is 2 sites only. It can be done with 3, but it does add complexity, which you'll actually see. So here I'm showing you kind of a picture of an NSX Multi-site. You see I got my NSX Manager cluster there, and that's it. Okay, you'll see I've got, in this example, I'm showing 3 locations. You could have 2 or whatever, right? Notice I've also drawn a vCenter server at each location. Technically, I don't need to do that. I could have 1 vCenter server across those. Okay, maybe these are racks. Who knows, right? But again, you've got a lot of flexibility here. Metro distance less than 10 milliseconds for simple DR. Remember, simple DR, they kind of refer to in the paper as an automatic recovery. Okay, I don't need to push a button. It automatically recovers. Now, Federation, again, is used for all other cases. So I got more than 2 sites. Again, we could do multi-site with 3 sites if we want to, but Federation handles it a lot easier. Your site-to-site latency now, we can go all the way up to 500 milliseconds. If you watch my Federation video, I mentioned RTAP to RTAP is 150. No longer anymore. It's now, as a 4.1.2, you can do 500 milliseconds between sites now. So a little update on that. And same thing, we can do up to 16 sites now. So see the config max. So again, that's as of recording as of November, or whatever, 20th that we're at today, 2023. Okay. So Federation, one of the things I'll just real quickly point out, we have this thing called a global manager cluster, standby global manager cluster, and then we have local manager clusters. So so these are VMs here, right? Whereas multi-site, I just got the 3 managers and that's it. So obviously very large footprint down here for Federation. And we'll take a look at some possible different configurations for that. So let's start off with multi-site here. So multi-site, I kind of mentioned this small footprint, single management plane, as I mentioned before. You got your 3 managers there, and that's it. It can be active or active standby your sites. We'll walk you through that. It also has the ability to do simple DR, so automatic recovery. This requires stretch cluster, so single vCenter environment. So maybe like a vSAN cluster across 2 sites or whatever. I'll walk you through that. Does require large MBTU between the sites. Supports pretty much all NSX features. I kind of mentioned that. I mentioned here check partner integration. So if you've got certain partner solutions you're using, you want to make sure, one, whether it's Federation or multi-site, that it's supported for Federation or multi-site. One of the things that pops into my mind on this is some partners, depending on the solution, utilizes service VMs, SVMs, service VMs. Now, these service VMs could reside on each of your transport nodes, on each of your ESXi servers, I should say, or they could be a service VM cluster, and it's usually like a licensing thing. Typically, the ones that in the cluster don't support multi-site, so you want to watch out for that. But anyways, like I said, always check the partner solution you plan on deploying. Will it work in your multi-site or not? From we talk about scaling multi-site, it's limited to 1 NSX management cluster, so whatever the scale limits are on that. Look at the config max. Management and central control plane require recovery, auto recovery with stretch cluster. So I mentioned this part about the simple DR. So simple DR is provides us with automatic recovery. There's options that there is no automatic recovery. You've got to press a button, okay? And we'll take a look at that. And that's what this is all about. And again, I'm showing you a picture here with multiple vCenter servers, 1 at each location. I don't have to, okay? All right, but that's just a picture. Now, Federation requires Enterprise Plus licensing. Again, as I mentioned before, no large MTU required between the sites. Again, we're not doing tunnels between each transport node. So from that perspective, NSX is more efficient, because if I've got 2 sites with 200 hosts at each site, technically, well, my math is going to be really horrible here, I'm going to have a tunnel with every host in every site. So that's a lot, okay? That would be multi-site. I would have a tunnel between every host at every site, whereas with Federation, we don't. We don't have to have a tunnel from host 1 at site 1 with the other 200 hosts at site 2. We don't have to do that, okay? We use RTAPs instead, so more efficient. Up to 150 milliseconds, I mentioned before. It does provide for simple DR, large footprints, as I mentioned, limited support set of features, and like I said, I'll throw a chart on that. And no support for VMware Cloud to on-prem. I've seen some questions on that one. As of today, anyways, I know there's no support for that. I don't know if that's changed. If you know anything about that, leave a comment below. All right, so why don't we get right into it now? Let's talk about multi-site. And what we're going to do, since there's a lot to digest here, I'm going to focus on management plane, control plane, okay? How we can deploy that and how we recover. Then I'll talk about the edge nodes, hence our data plane as well, okay? Then after we talk about multi-site, we'll go through and look at Federation. So this is going to probably be a pretty long lesson. All right, so one of the things I mentioned before, our deciding factors, is the latency between sites. So one of them, if you're less than 10 milliseconds, that gives you certain options. So for example, I've got this one up here at the top, I've got 2 locations, and I have my management cluster stretched across those 2 locations. That's the NSX management cluster. Or if I got 3 locations, again, as long as I'm within that less than 10 milliseconds, again, I can put a manager at each location if I want to, right? We do support layer 2 stretching, so you got to stretch your management network. You're not having NSX stretch it, because that's like NSX relying on NSX for the stretching, like chicken and egg, right? So you have to stretch the layer 2, however you do that. And then you can, or you could use, and the advantage of that is you can use the NSX virtual IP. So again, that's the native IP that you could use inside the NSX manager to manage or to access the management cluster. Or you could put each manager on a different layer 2 network. And I talked about this in our manager video. So each manager can be on its own subnet. And at that point, you need some kind of load balancer, external load balancer, to manage it, okay? So you have both those options, whether it's 2 sites or whatever the case may be. So let's look at this one here. So again, we're less than 10 milliseconds. In this example, I'm calling it simple DR. Why? Is because we got a stretched vSphere cluster. So between our locations, again, these could be racks or buildings, okay? Between our locations, I've got my vSphere HA cluster stretched across it, okay? And in order to do that, I have to have some kind of storage that's stretched as well, because we're going to use vSphere high availability. So these NSX managers must reside on this shared data store. So this could be something like vSAN, or if you got really deep pockets, it could be, actually you don't really have to have really deep pockets for this one. You could be just stretching your storage across, a campus or something like that, right? The advantage of this one, again, this provides for automatic management and central control plane recovery, which we'll see. Recovery is about 10 minutes, 15 minutes, depending. And what that's referring to is we're restarting up a VM. HA host rules, managers VM should be on one location. So in this example, we're showing you that the NSX management cluster is on one location. And it says it requires stretched storage. Now, I made a little bullet here, see storage requirements. Now, I know I'm saying less than 10 milliseconds. Why are we saying that? Is because, remember, the NSX manager has a core food database. And whenever you update the database on one manager, it synchronizes that configuration across the other 2 managers. So that's synchronous, not asynchronous. It's synchronous. So the latency we require between our managers, the maximum is 10 milliseconds. So this is now for doing a stretched storage, for example, like vSAN, that's typically 5 milliseconds. So that's going to be your lowest common denominator. Like, oh, okay, we're 7 milliseconds between our sites. I can't do this, right? Unless you've got storage that allows you to do it, some other storage, okay? So be aware of that. So you got to really look at your storage requirements here. The advantage of this one, again, if something happens to location 1, it's gone, it's nuked. At that point, HA kicks in starts up the managers over here, just like just like it would. You've got a bunch of hosts over here on this site. The managers fail on, or sorry, location 1 dies, so we lose all the hosts in location 1, and then at that point we basically have our management cluster started up. Okay, and again, simple DR, we automatically start it. It takes about 15 minutes, 10 to 15 minutes to start up your managers. And by the way, while the managers are down, the central control plane is down, you're not allowed to do vMotion or distributed resource scheduler at that point. Now, I'm not talking about virtual machine recovery here. I'm talking about just management and control plane recovery. Obviously, if there was VMs running over here, which there was, it would restart back over here. So what you would want to do in this situation is say, create a rule saying 3 managers should run at location, like a DRS anti-affinity rule, saying the managers should run on these hosts at location 1. If all of them die, then we can run over here on that location. Now, if you're less than 10 milliseconds, why do that? Why have all 3 of your managers at one location, right? This would be a better solution. In fact, it's considered a good practice. I don't like using the word best practice, okay? If I got less than 10 milliseconds, the same kind of thing here, I was doing a stretch vSphere cluster, I could put 1 manager at location 2 and 2 managers at location 1. That's fine. So now what happens if location 2 here dies? Management and control plane is still up. Managers 1 and 2 are still there. We did not have an outage in management and control plane. However, we lost location 2 where manager 3 was running, so vSphere HA would restart that onto that host over here. But that's okay. We still had 2 hosts or 2 managers. So management control plane, there is no outage. So that makes sense, right? Cluster quorum was maintained. No management or control plane outage. Manager 3 is recovered at location 1. And you create these anti-affinity rules and stuff. Okay? So that's kind of cool, right? Now, how about this? Suppose if location 1 died. Let me clear all this. Okay, so let's say location 1 dies. Again, we still consider it a simple disaster recovery because it's automatic. We're using that vSphere HA again, like we talked about. So we lost managers 1 and 2. So we need to restart managers 1 and 2 at location 2 now. That takes time. Now, hang on a second. Some of you are going to say, well, Steve, we lost 1 and 2. Manager 3 is still up. Isn't it still up? Isn't the management control plane still functioning? And the answer is no, because again, watch my video on the NSX Manager failures and recoveries. I actually talk about it there, right? If I come back over here, yeah, just go back to this picture. If I lose managers 1 and 2, manager 3 is still there, but I would lost quorum. Manager 3 will say, I can't see 1 and 2. I must be isolated. And basically it goes into what's called read-only mode. Essentially disconnects from all transport nodes, and it's essentially doing nothing. Okay? It may as well have failed. So at that point, if you lose location 1, managers 1 and 2 are gone. 3 is still there, but it's not functioning as a cluster. Now you do have an option. As I mentioned before, you got vSphere HA. It fails, it starts up the managers 1 and 2. It starts them up, and it takes about 10, 15 minutes for it to recover. So that's, again, automatic management plane recovery. It takes about 10 or 15 minutes. Again, no vMotion or DS allowed while this is going on. Now, suppose I just made a little note here, deactivate cluster options available. I wanted to mention this. It is talked about in the design guide. Let's say you're having a really bad day. First of all, let's change the slides here. Let's say, let's try this again. Let's say you're having a really bad day. Let's say, first of all, you're not using a vSphere stretch cluster. Let's forget about HA for a minute, okay? We're not using a vSphere stretch cluster. So there's 2 different vCenter servers here, okay? Or actually, they don't have to be. But anyways, now, all of a sudden, you lose managers 1 and 2. Somehow, maybe they are on the same data store, and they got completely corrupted, and they're gone. They're never coming back, okay? You can go in to this manager here, go into it, and run the deactivate cluster option. And what that does, it'll say, oh, I'm manager 3. I have a manager 1 and a manager 2, but you're running the deactivate cluster. You're saying, I'm going to return this thing to a single node cluster. And what will happen is you're saying, okay, I'm making this thing a single node cluster, and then it's going to restart, and then at that point, within about 10 minutes, it comes up available as a one node cluster. Now, I do have a video on that, okay, recovering from multi-node failures for managers, so you're going to want to watch that. So this is an option. Now, this is a last-ditch resort, because if you know, oh, hang on a second, you know that these guys are going to come back, don't do that, because once you go deactivate cluster on manager 3, manager 1 and 2, if they come back, too bad, throw them in the garbage. You got to reconfigure. You got to redeploy, okay? It will not accept them back. So that deactivate cluster, you just don't do it because you feel like it. You go, well, oh, there's a WAN outage here, right? Or something like that, and you need, for whatever reason, get the management cluster over here. You don't really want to do it. So if you know managers 1 and 2 are gone, they're never coming back, you can do this deactivate management cluster. And then once you do that, once you deactivate the cluster on that one, you can then deploy a second and a third manager, brand new, and add it to that. It'll now be a cluster of 3, okay? So just watch out for that. I didn't do a slide on it because, well, I was lazy. So that's why I mentioned here. Now, suppose if you don't have, you got more than 10 milliseconds between the sites. So 10 to 150 milliseconds and no congestion. So at that point, guess what? Whether this is 1 site, 2 sites, 3 sites, I really don't care. Your management cluster has to run on at 1 site. So as soon as you have more than 10 milliseconds latency between your sites, you have to run your management cluster at 1 site. No ifs, ands, or buts. Now, how can we protect it? Again, since we've got this 150 milliseconds here, you're probably not doing stretch clustering at that point, like I was talking about. Generally, that's usually at 5 milliseconds or less you need, right? But anyways, so you're not doing any stretch vSphere cluster. In this example, you see I got a vCenter on site 1 and a vCenter on site 2. I'm using a product called Site Recovery Manager. So I'll have it at both. Site Recovery Manager, I'll do some videos on that later, allows us to will recover from a site failure, right? And it does other stuff for us as well, right? So it says vCenters at both locations. Management cluster must run at 1 location, as I mentioned before. And we use SRM to recover the management cluster. So in this example, sorry, let me point this out here. So when we go to protect our VMs with Site Recovery Manager, so here's our VMs, the 3 VMs, it creates what's called these placeholder VMs. That's why I've got these ones a little bit lighter in color, just to show you they're kind of just a placeholder VMs for our management cluster. When there's a failure, okay, you have to do a manual recovery via Site Recovery Manager. So there is no simple DR. It's pretty simple, to be honest with you, but it's not automatic. So you got to go into Site Recovery Manager, press a button. You got to run the recovery plan, okay? You got to press a button to recover the management cluster. So then it starts it up on the site there. I'll do videos on Site Recovery Manager. You could script it if you wanted to and automate that. I'm always a little bit leery about doing something like that. Suppose if there's a false positive and Site Recovery Manager decides to recover accidentally, right? So I'll leave that up to your decision. So we do have a management plane and control plane outage. Recovery here is going to take about 15 minutes. Probably a little bit longer than that because we now need to, well, not necessarily. We basically have to start up these VMs, the copies of them. Again, while management control plane is down, there's no vMotion or DRS. You may lose most recent manager changes. What are we talking about here? Remember what we're doing with Site Recovery Manager is we have our VMs running over here at location 1, and we're making replicas of that over here. Now that replica in this example is not synchronous in nature. It's more than likely going to be asynchronous, and it's going to be based on a recovery plan. I guess the question comes down to, how are we replicating these VMs over to the second location? And there's two ways you could do it. You could use it. Hardware is one way. So you got storage over at one location, storage over another, and you're replicating the LUNs or the VMs, depending on the type of storage, you're replicating that across. And depending on how your storage works, is that replication going to be synchronized, or asynchronous, basically a little bit off sync, all right? So usually with 150 milliseconds, it will not be synchronized or synchronous replication. So this is why I put down here, depends on recovery point objective. Now, Site Recovery Manager also could utilize our product called vSphere Replication, right? So, and we can have a recovery point objective of like 5 minutes, minimum of 5 minutes. So what that means is you might lose some recent manager changes. If you made some updates, and all of a sudden the disaster had happened, and the replicator didn't get enough time to replicate that change, you might lose that. But anyways, at least your management control plane will be back up. So there is an outage here. Compute recovery, I haven't been talking about that. I've just been focusing on management control plane. But compute recovery, again, in this example, a Site Recovery Manager can help you do that. Now, one of the questions I sometimes get is, can you change the IP address of the managers? And the answer is no. Okay. Now this one example here, it's in the guide, the multi-site best practices guide. Like I said, I'll leave links for that in the comments. But a little fruit fly there. But you can actually do a recovery based on a backup. Now, this is not a pretty one. This is probably one most people aren't going to do. But this one's been around the longest, to be honest with you. To me, this is probably not the greatest solution, but hey, you know what? It works. Okay. So I got location 1 and location 2 here. Now, one of the things I wanted to mention was, notice this one here. In this location 1, I have management 1 LAN. So this is a layer 2 network, right? And then for whatever reason on your recovery site, you need to change the IPs of the manager. For whatever your reasons are, it cannot be the same layer 2 network. Maybe that network's being used by something else at that location. So you need to change it. So the question sometimes you get is, can Site Recovery Manager has the capabilities of re-IPing your virtual machines, your workloads. It can do that. It's one of the cool features of it. It doesn't work with our NSX managers, so you can't use it. So how do we do this? This gets a little ugly, okay? So if you need to recover the managers over here and re-IP them, the transport nodes, all your transport nodes, your edges, and your ESXi host is looking for them based on their IP address. Transport nodes don't care about the NSX manager's fully qualified domain name. They go by default the IP address, okay? So now if we're going to restore it over at another place, well, we're going to change the IPs. Your transport nodes aren't going to be too happy about that. So how do we do this? Okay, well, first of all, we got to set up our managers in DNS. You should probably already have that. So you'll have your forward and reverse lookup set up in DNS for your managers. And they'll have the IP addresses of location 1. Okay? And you're going to give it a very short time to live, 5 minutes. Okay? Then you're going to, you need to set up the managers so that the transport nodes, your edges and your ESXi host, doesn't use the IPs of the managers to connect to. That uses the fully qualified domain name. And that's done through NSX registration with the REST APIs. So you have to do that with the APIs. Then, that's not fun enough, then you need to set up a scheduled backup, a continuous backup of your management cluster over to here. Again, how you back up, I haven't done a video on that. I'm going to do a video on it. You basically, within the manager, you have it do a backup to a secure FTP server. So this would be a secure FTP server, okay? So you're doing the backup, and that secure FTP server is on your recovery site, okay? So now all of a sudden there's a disaster. Boom, we lost location 1. All our managers are gone, okay? So you then need to go into your DNS and update the records of those managers now with the new IPs of location 2. Okay. Remember, you only gave it a time to live of 5 minutes. So, hey, believe me, once you update that, it's going to take you longer than 5 minutes to recover everything else. You then redeploy the managers on site 2. Okay. I would probably just deploy one first and then do a restore and then deploy the second and the third after that, right? So you need to deploy it. That takes a while to deploy. Probably a good idea to maybe have it pre-deployed and sitting there ready to be powered on. Okay, so it's a fresh install, nothing else. And by the way, the versions have to be the same. If you're 4.1.2 over here, better be 4.1.2 over here when you're doing a restore. Okay, so you deploy a new manager or you have one already there to power on. Then you go in and you restore it from your backup. You do the restore from the backup. And once you've done that, all the transport nodes and edges will reconnect to that new management cluster. This, they say, well, how long is it going to take you to do this? It could take like an hour or so recovery. So this is probably the ugliest of them all that I've talked about so far. Honestly, hey, you know what? I'm sure there are people out there that have to do this, right? So, but anyways, that's another option. Okay, so that was multi-site with the NSX management plane and control plane. Like I said, there's lots of variations there. The really nice one, as I talked about, was the stretched storage, right? The problem with that is your data centers are going to be really close to each other. So that doesn't really help you out much. If there's a hurricane coming in, your data centers are probably very close. It's going to affect both of them. The nice one, the site recovery manager one, actually gets around that issue because, again, you could be further away. Your data centers could be much further away. You could have one here in Toronto, another one in Montreal, or something like that. So if there's an ice storm in Montreal, it's not going to affect Toronto. But anyways, I digress. All right. So let's jump in, talk about the edge nodes, how we can deploy those, and that's our data plane. Okay. See you in a second. All right, thanks for sticking around. Hey, if you like this stuff so far and you haven't subscribed to the channel, please subscribe to the channel. I'd really appreciate it. I want to hit that 1,000 subscribers. It would be nice to hit it by the end of the year, but hey, I'm not sure about that. But we'll see, okay? Let's talk about multi-site still, but let's talk about the edge nodes, how we can deploy those. So again, just like I mentioned before, when we talk about multi-site and federation, you got to think about latency and stuff. Same thing with the edge node deployment. It's going to dictate what your options are, okay? So first of all, there's 2 modes, and it's based on latency across your locations. So below 10 milliseconds, you can go active standby using edge failure domains. That's what VMware recommends. And you might think, that doesn't make sense to me. Hold on to that thought. There's actually a third option here. And I'll show you that. I didn't label it here, okay? So anyways, they say anything below 10 milliseconds latency, you can do active standby with your edge clusters using failure domains. So you basically, what you're doing here, and that's in this picture down here, is you're creating an NSX edge cluster, not a vSphere cluster, don't get confused, an NSX edge cluster across your locations. And we can do that stretched edge cluster because the latency with your... When you create an NSX edge cluster, the edges in that cluster can't have anything more than a 10 millisecond latency between them, okay? There's this thing called failure domains. Failure domains prevent active standby edges running in the same location. Unfortunately, I don't know if there's any change in 4.1.2. I honestly haven't looked at it. But that has to be done through an API call. And what that prevents you from doing is having your edges, your active and standby edges, on the same host per se, or same location in this example. Failure domains are configured through the APIs. This option, your north-south throughput is limited to a single edge node, so that you might go, ooh, that's not good, right? So you got one location, all the traffic is going in and out of a single edge. Now, if that's a virtual machine edge, typically that could be somewhere in between around 10 gigabits per second. It's got the VMXNet 3 drivers. Let's say if you've got 2 interfaces going north and 2 interfaces going south, so 2 on a VLAN, 2 on overlay. So that would be, let's say, 9.5 gig per, so let's say 18, 19 gig max on that VM. Physical box, if it's a physical box, well, how fast is your network card? Okay, so again, the edges don't have to be a VM; they could be bare metal. Okay, so again, something to really think about in this type of solution with a stretched cluster. No requirements for vSphere AHA. Again, we don't need a stretched vSphere AHA environment. Our NSX edges can be active, active, active standby. But we're talking about active standby here. Above 10 milliseconds between sites, your tier zeros can be active, active with equal cost multipathing with an edge cluster at each location. So you might look at this and go, what? Above 10 milliseconds, we can do active, active. The reason why is you're doing an edge cluster in each location. So notice location A has a cluster A here, and location B has an edge cluster B. And both of the edges, I'm just doing two edges in here, but remember you can have up to 8 edges inside a NSX edge cluster. In this example, I got an active edge here and a standby edge over here. Okay? I did say there's a third option, but we'll save that for last. So, stretched edge cluster, active standby. So, first of all, just making sure I'm recording. First of all, you want to make sure it's less than 10 milliseconds. As I mentioned, your edges in the same cluster that's the maximum latency between them. We do need a large MTU across the sites. I've already talked about that. No need for vSphere's high availability because this is outside of vSphere. We don't rely on vSphere's HA. This is part of NSX configuration. Provides for automatic failover. No local egress. You'll see all the traffic will go in and out of one location. Data plane outage approximately 3 seconds. We'll talk about that in a second on how we fail over and stuff. And split brain, I'll talk about split brain later on. Let me clear all this. So right now you see here I've got 2 locations, A and B. We're less than 10 milliseconds between them. I create an edge cluster. This edge cluster is going to span these 2 locations. Now I didn't draw a picture of this, but again, there could be a vCenter server here and a vCenter server over here. Or there could just be a single vCenter server. Makes no difference. So here's my edge cluster. Now I create what's called failure domains. And I mentioned before, you got to do that with the REST API. So I'll make a failure domain for location 1, failure domain for location 2, and then I'll make sure that my edge node 1 is in failure domain 1 and edge node 2 is in failure domain 2. The reason for that is we don't want edge node 2 running on location 1 because that would be silly, right? So we want to make sure we keep them on separate hosts. So again, we have our failure domains here. You'll see again I've got a tier 1 gateway here. It's a distributed router only. There's no services. I got a tier 0 gateway. Now this tier 0 gateway is set up as active standby. So it's running actively on this edge node. So the in and out traffic goes through the SR component of that edge node down there, right? So traffic goes in and out through this edge at that point, okay? Now, what happens with the standby? Does it sit there and do nothing? Technically, it doesn't. We do set up peering. In this example, I'm using BGP. So this blue network is advertised out from tier 1 to the tier 0. Tier 0 will redistribute that to the physical world, to its partner gateway above, right? And so it's going to learn, let's say in this example, I'm using BGP. It could be static routes, no OSPF, okay? No OSPF. Now, what does the standby edge do? Does it do nothing? No, it actually advertises it out as well. But it advertises it out by prepending the autonomous system number. In other words, it advertises it out with a worst cost. In other words, it's a worst cost to come in this way. So all my traffic coming for the blue network will come in through this location A, okay? And not through here because it has a higher cost. If there's a failure, again, because this has a higher cost, basically the standby becomes active, and at that point, all traffic will come in through this direction and will go out through that direction if there's a complete location failure, okay? Virtual machine, like if location A here failed, I'm not talking about workload redistribution. Again, if you're using something like Site Recovery Manager, you would recover your workloads like that or whatever else. Okay, so this is automatic recovery. It's pretty quick. It's going to depend on your timers. Like I'm not a BGP guy. I refer to them as like hello and dead timers, right? We also use bidirectional forward detection with our edge nodes and our BGP peers. We have that capability to detect failures. And depending on if it's a VM edge or bare metal edge, dictates how often that bidirectional forward detection failure occurs. Is it every 50 milliseconds, like in bare metal, or is it every 150 milliseconds? I believe it is on VMs now. So again, so that's kind of cool. Now, I'm going to take this one step further and show you 3 locations. Okay? So this one here gets a little bit complicated. Remember I said multi-site, sweet spot's 2 locations. You can do 3, but it does add levels of complexity. Well, here's one of those levels of complexity. So my blue network, again, my blue network is exactly what I just described over here. Okay? We're still running active standby. There is the blue network's cluster. Okay? The blue network comes in and out of location 1. Okay? Notice I stretched it over to location 2. It's the only difference between the other picture. Now, notice on location C, I've got a purple network. Let's change my colors. I got a purple network that's stretched across. I got a purple tier 0, a purple tier 1. Same kind of thing. And I've got we'll call it the purple edge cluster. And that edge cluster runs active standby with a failure domain in location B and another failure domain in location C. And you'll see over here, the edge here in location A or C is the active for the purple network, and this edge in location B is the standby. So all traffic, let me clear all this, all traffic for the purple network goes in and out of location C. All traffic for the blue network goes in and out of location 1, or location A, sorry. Okay? Great. We see that location B here is kind of acting as a disaster recovery site for both. So again, as I pointed out, if I go back in one slide, again, if we lost this site, right? Location B, we fail over to location B. Again, our traffic goes in and out through that location. Same kind of thing here. If again, we're advertising the blue network at location A. We're also advertising it at location B, but at a higher cost. Okay, that's automatically done for us. And then you'll notice over here in the purple network, again, we're advertising the purple network out via location C. We're also advertising it out location B, but at a higher cost because that edge is in a standby. Okay, so that's part of how the active standby of the edge works. Now, workload failover, okay, that's a different one altogether now. Typically with Site Recovery Manager, 2 locations, it's easy peasy. Site Recovery Manager, when you get into 3 location, adds some fair complexity at that point. I could have these VMs replicating to Site B for protection, these VMs replicating to that site. I can't replicate these VMs here to Site B and Site C. I can't do that. Okay, so like I said, sweet spot's 2 sites, can do a third, but it adds complexity. Now, I put together this slide because inside the design guide, they actually show you, notice in my cluster here, I got one edge here active and another one standby. Here's another cluster down here, one edge active, the other standby. When I looked at the design guide, I seen something like this. I got 4 edges inside this cluster, and 2 of them are active and 2 are standby. I go, what? That doesn't make sense. What they're trying to show you remember I said with this active standby, the traffic in and out of locations limited to the throughput of 1 edge. Okay. The reason why I threw this one in here is this same cluster can be used for services. Maybe you're throwing services on the tier 0 gateway like NAT, and you're going to say, okay, NAT's going to use edge 2 as its active and edge 2 as its standby. Okay, so my traffic here could be going through edge 1, and edge 1 standby is the backup for my in and out traffic. And then for the NAT, I'm using edge 2 as my active. And so you can do something like that. Personally, I'd probably create a separate cluster for those services instead of murking up the water a little bit. So I just wanted to point that out. Again, these services can be for your tier 0 and tier 1. I only threw some pictures of the services here. That's it. What about non-stretch? Actually, before I do that, what happens if there's a split brain here? Let's say there's communication drops between location A and location B. What will happen is, obviously, it's not going to impact on the blue network, all the machines there going north and south. It's not going to impact them whatsoever. It will not impact communications on the blue network between location B and C, but obviously between location B and C and A, it won't work, right? It will impact communication on location B. Technically, nothing north. Actually, no, it would affect north and south as well, because this is still going to have a higher cost. So it's going to impact north-south here, but not north-south over on location A. So if something should happen, if you lose communication between the sites. Let's look at active-active, non-stretched edge clusters when our sites are all the way up to 150 milliseconds apart. So more than 10 milliseconds, less than 150. Diagram looks very much the same, right? The only difference here is we're not doing a stretched cluster. You'll notice each location has its own edge cluster. And technically, they could be running an active standby or active-active. So that's fine. So you could be using equal cost multipathing at your locations if you want to, right? So same kind of pictures before. Again, you could do this. Imagine if you just had two sites, you could do the same thing with two sites where they're backing each other up. Or again, in this example, I'm just showing three sites, just like the design guide. So my blue network again is going out. Let me clear all this. The blue network again is being advertised and going out through location A. The purple network is being advertised and going out through location C. Nothing's different there, okay? What the big difference here is this. Let me get, what color do I want? I'll get orange. Notice over here on my location B, I'm going to deploy a tier 0 gateway, another blue tier 0 gateway. This one is not representing a, oh shoot, it says standby. It's not representing that. Let's get technically it is. We're not doing active standby with edge clusters anymore. You're going to deploy a tier 0 gateway here, like blue tier 0 gateway blue redundant. And notice it's not connected to anything. There's no connection there. I don't have a connection going to that tier 1. And I'll do the same thing with the purple. I'll deploy a tier 0 gateway. Don't connect it to any tier 1s, okay? So it's not going to advertise anything out. At this point, if something should fail, let's say location A dies, again, you'll need to manually go in and make that connection to the tier 1. At that point, it'll start advertising out routes, okay? So that connection, there's no automatic recovery. That connection is manual. You need to do that, or you could script that if you want. You'd probably script it if you're going to do it, okay? Again, no failure domains are required here because our cluster is within our sites. Our edge clusters are within our sites. And again, we've got a edge cluster for each site in this example. I'm showing services as well. That cluster could be using services or have another cluster for services, but it doesn't really matter. Okay, so those was our two choices. You had less than 10 milliseconds, active standby on the edge cluster, stretched cluster, or you had more than 10 milliseconds and you went active with clusters at each location. There's a third option, and this is kind of a special one. Okay, what about multi-site with active stretched edge cluster? This is going to get interesting. This is what they refer to as a heavy cross-location traffic. You need at least 10 milliseconds. There's no need for vSphere high availability, and we're going to have asymmetric routing to contend with as well. So when we look at this picture, I've got sites A, B, and C, right? 3 locations. And we've got our, NSX networks that we're going to advertise out to the real world. And notice we're going to advertise them out at equal costs to the real world. We have local egress going on, but the issue here with asymmetric routing is this VM on location C might go out to the internet, and then the return traffic might come in through location A and then across like this, right? So that's something you're going to have to keep in the back of your mind, right? Now, this is where it gets really fun. Okay, I got no services here, so I got my tier 1 and DR mode only, no services on it. and I got my tier 0 and active. So potentially what happens is when you got a VM, this is a 2-tier model. So when we want to get out to the real world, we go to our tier 1 gateway first. So that's basically going to be right local on our host. Then we go from our tier 1 to our tier 1 DR. Then we go to our tier 0 DR because we have no services on the tier 1. So that's going to, again, still be on the same host. So that's why you see this path going straight up. Then once we're on, if you don't know what I'm talking about with SRs and DRs, you need to watch my routing, okay? So when we go from the DR of our tier 1 to the DR of our tier 0, we're still technically on the same hypervisor. But now we need to get out to the SR component. Where does the SR component live? It lives on an edge node. And that's what I'm trying to illustrate in this picture. We're coming out, and now we're going to go hit the edge node. And that could be an edge node that's on any location. So technically speaking, this VM might come like this and then shoot out here to get to the outside world, okay? Because of that, because we're using equal cost multipathing across our edge nodes, okay? Now, what happens if we put a service on our tier 1? So here we decide to throw a service on there. So again, this is a heavy cross location. Again, you still need that 10 milliseconds or better. No need for vSphere high availability. But we're putting services on the edge on our tier 1. Maybe it's NAT or whatever we're doing, right? And then it says tier 1 services run on the same edge node as our tier 1 services. So as soon as we put a service on our tier 1, it now needs that SR component. Where's the SR component run? It runs on an edge. Hey, just by chance, if that edge is the same edge that your tier 0 is using for routing, great. And that's what this picture is showing. So potentially what's happening here is all these now have to go through this one location. It has to hit that single edge node that's providing that service for the tier 1. That runs in active standby, by the way. Okay. Then if it's on the same edge node as the tier 0, no problems. We shoot out. Done. Again, in this example, asymmetric routing quite possible. Actually, I don't have notice that my slides here because we can come back in through this way. Right? Now, how about this? Again, we have services in our tier 1, but what's the difference here? Now we're going to give that tier 1 services and have it run on a different edge node. Maybe you got an edge cluster for the tier 1 services and you got an edge cluster for the tier 0. Quite common, okay? So in this case, again, all our VMs got to go to that SR for the tier 1 service, okay? So that's running on an edge node. And then that edge node needs to send it out to the tier 0 DR component, which will be on that edge node. Then it's got to go out to the SR component of that gateway, that tier 0 gateway. So at that point, it could go out the same host or across different locations. So this can get a bit funny, where I could do something, potentially I could shoot like here, hit the SR on that edge node for the tier 1. Then I got to go hit the SR component for the tier 0. That might be here on location C and then shooting out. So it can get really fun. This, again, they refer to as a special situation with heavy cross-location traffic. Something you might want to stay away from, unless maybe they're not locations, maybe these are racks inside the same data center. Yeah, okay, you're really low latency, may not matter so much, but you really got to kind of think about this one. And that's it. So we're going to talk about Federation, all right? Stick around. By the way, if you haven't hit that subscribe button, hit that subscribe button, huh? Or do me a big favor if you did that. Thank you. So let's talk briefly about Federation. Just the first few slides are just reviews. If you're not familiar with it, watch my Federation video, okay? Federation requires your Enterprise Plus licensing. The advantage of Federation also is between the sites, we don't need a large MTU, a maximum transmission unit size. I talk about these things called RTEPs in my Federation video, and it allows us to fragment those Geneva frames between sites, whereas multi-site, you can't do that, okay? So no, and also no direct tunnels between sites on the transport zone, whereas with multi-site, there'll be a tunnel between all your transport nodes, edges, your ESXi host, and all that. Whereas Federation, we don't have to do that. We just maintain tunnels between the RTAPs from each site. We now today, as a 4.1. Whatever, we allow up to 500 milliseconds round trip. Okay, so a lot more latency than multi-site. Simple DR, again, both of them have their pluses and minuses. Simple DR, simple disaster recovery, automated data plane recovery. We'll look at a couple of those things, but this really depends. Downside here is a very large footprint, which we'll see in a second. Also, another downside, limited feature sets are supported. For example, certain partner solutions may not work in Federation. You got to look at that. IDS, IPS, intrusion detection, intrusion prevention, malware. Those things aren't supported. From a federated perspective, so you want to look at that. No support for VMware Cloud to on-prem as well with this. So when we look at this slide here, just a quick recap on Federation. You see I've got multiple sites here. Today we can go all the way up to 16. It's pretty crazy. You'll see we have a thing called a Global Manager Active Cluster and a Global Manager Standby Cluster. So when we create an object that's going to span multiple sites, it's typically called a global object. I'm going to create a tier 0 gateway that's going to stretch across sites. That's a global object. We also have the concept of regional objects. I could create an object that only spans certain locations. That's called a regional object. Okay, I could even create objects that just span one location. Again, that's a local object. So we still have that capability. So global objects, regional objects. Whenever you're creating an object that's going to span multiple locations, whether it's global or regional, you do it all from the Global Manager Cluster. Now, one of the things, if you haven't noticed already, this thing has a pretty heavy footprint. So I've got my local manager cluster. That's your NSX manager cluster. Remember, you got 3 nodes. Now, in my example here, I got 3 locations, so that's 9 altogether. Then I have 3 for my global manager cluster and another 3 for this standby. So again, that's 5 times 3. That's 15 appliances. Now, if we go all the way up to 16, you folks do the math. Pretty heavy footprint. There are advantages of that because now each location has its own. This is actually a management and control plane. Management for that location and control plane. This up here is management only. There's no control plane. Okay, so what's it manage? It manages objects that are going to span multiple locations. Notice again, as I mentioned before, you got 3 of them here, right? So pretty heavy footprint. I think that's about it. Yeah, we'll look at some configuration options here. Okay. So let's talk about, just like we did with multi-site, let's look at management control plane first, then we'll take a look at data plane, right? It's a little easier to break it down like that. So here we see, when we talk about NSX managers, even in multi-site, if your latency between your sites are less than 10 milliseconds, great. You could actually put your managers on different sites because remember the latency between managers got to be nothing less than, can't be anything more than 10 milliseconds because we've got to synchronize that core food database. So in this example, instead of me doing a, global manager that sits at one location and then another standby that sits in another location, I could save a little bit of resources and I could specify my active global manager cluster. I'll deploy 1 at each location as long as, again, I meet that latency requirement. The advantage of this is if I lose a location, again, my management, my global manager cluster is still functioning. You've got 3 of them. If you lose 2, it's now dead in the water. Your global manager cluster, you could do a deactivate cluster on this one to bring that back up. But again, you got bigger fish to fry probably, right? So global manager availability, even in the event of a single location failure. So if you got 3 locations, 10 milliseconds apart, yeah, you can put one manager on each. Perfect. You don't really need a standby global manager at this point. Local manager service on remaining locations not impacted. So again, in my first example here, if I kill location 1, again, yeah, location 1's gone, it's toast, but I still have a management and control plane at location 2 and 3, right? And I still even have global manager as well. So this addresses the needs of having management and control planes in different sites and redundancy there. So that's kind of a cool thing, right? Here in this example, we're showing you a stretched layer 2. So these managers are all on the same subnet along here, okay? And with that, I could use the cluster manager virtual IP, or I could use a load balancer if I wanted to talk to these. So I have flexibility there. Now, another option you have, let's say for whatever reasons, you go, well, I want to deploy a global manager cluster, a global manager at each of my 3 locations, but they have to be on different subnets for whatever your reasons are, okay? So we'll see manager 1 is on this one subnet at location 1, manager 2, again, these are global managers I'm talking about. Manager 2 is on a different subnet here at location 2, and the third manager on location 3 is on a different subnet. Obviously, you cannot use, because they're on different layer 2 networks, cannot use the global manager virtual IP. You must use a global, some kind of load balancer at this point, some kind of global load balancer. And by the way, all this stuff I'm talking about, if you lose a site or whatever, like in this example, still if I lose a site, I'm okay. You want to make sure if you're using some kind of global load balancer, you want to make sure you have that set up for high availability as well. So this is kind of a nice example where technically I don't really need to deploy a standby global manager cluster. I could spread my global manager across 3 sites long as I hit that latency. I don't go over that latency requirement. Let's say you do go over that latency requirement, then you have no choice. Your global manager active cluster must stay at one site. The standby global manager cluster must be on another site. I can't spread them across. Okay, so in this example here, we see again location 1 has the global manager active cluster, location 2 has the standby. And again, remember, each location has its own local NSX manager cluster as well, managing that location. Again, I don't go too far down the rabbit hole on this one. Watch my Federation class. So so in this example, if we lose location 1, data still flows. From a management perspective, let's just talk about management, right? Control plane is still functioning over here at location 2 and 3. Location 1, it's toast, it's gone. But I now need to go into this standby global manager cluster and promote it. I can go in and say, okay, you're now the active, and I'll make this now the active if I want to, okay? Local management service on remaining locations, that's including central control plane, and management still functions. So again, even though we lost location 1, which happened to have our active global manager cluster, that's okay. Control plane still functions on the surviving locations, and we can just quickly click a button within a few minutes or so, depending on your environment. My global manager, I can promote that to an active global manager, okay? Now let's look at data plane. For the most part, management plane is pretty straightforward, to be honest with you on that. Let's talk about data plane. This is just a couple slides I pulled from my Federation stuff. When we talk about gateways, we got our tier 0, tier 1 gateways. You could deploy them in a couple of different ways. So this is talking about, like, for example, my tier 0, or if it's a tier 1, I could deploy it as an active standby. So if I decide I'm going to put services on my gateway, that services requires an edge node, which requires an edge cluster. And can I run that? Well, I can run an active standby. Like in this example, this edge is active. All traffic's going in and out of it. And here's the standby. In case that edge dies, the edge node 1 gets promoted, okay, to active. This is applicable for tier 0s and tier 1s. Tier 0 now, this is only Tier 0 only, this is active. By the way, this also from a routing perspective applies to Tier 0. So again, whenever you need when you got your Tier 0 gateway hooked to an uplink to go to the outside world, you need an edge cluster. Well, how am I going to do my routing? It's done with these SR components that run on edges. It can be active standby or active using equal cost multipathing. So this is kind of just a review even just from NSX. So active, both edge nodes, traffic goes in and out. Now that's active standby. What about locations now? With locations, we have a couple different ways. We can implement Tier 0 active standby. Remember, we just talked about that. So on location A, this edge here is the active one. And on location B, this edge is the active. So that's traffic's going through it. Now, the big thing here is the primary, secondary. So my locations, I'm going to pick location A as my primary. And my secondary will be location B. So you'll see all traffic in this example flows in and out location A. Even if it's got to go in or out from location B. And you kind of see that in my picture here. So if a VM wants to get to the outside world, it goes through here. The single edge goes through the active. So we only use the active edges in this example. If that edge fails, then we flip over to that survivor. Okay? That's the standby one. So active standby, primary, secondary. That's our locations. Then we can do active, which we talked about. Both edges at the location are both active. And again, we can do primary, secondary as our location. So same thing as before, but instead of using one edge, we're now using two edges at our location. So again, all traffic, when we got a primary, secondary, all traffic comes in and out of our primary location. In this example, it was location A. So you kind of see that, okay? So there's no local egress here. So anybody in location B has got to go across to location A to get out to the outside world, and then location A can just go in and out. It's got local egress. Location B does not have local egress. Last one. Active, all locations primary. So locations is what we call all primary. This is local egress. So no, again, you got location A can go out and come back in on itself, and then location B can go out. Now, one of the things that this potentially has problems with is if this machine out here is going out to the internet, technically it could come back in this way and then come across. And physical firewalls, stateful firewalls don't generally like that. It's called asymmetric routing, and they generally drop it. So in this type of solution, it looks really good. Hey, we got local egress on all our sites, but it opens up another, potential problem with asymmetric routing. So you got to think about that. And the last one here, I just threw this in because sometimes you get the question. This is active standby, all locations primary. That's not supported. I guess it doesn't mean it doesn't work, but it's just not supported. All right. Now, since we're talking about data plane, so we have to go through that to understand our active standby, all locations primary, or primary and secondary. So we have to understand that, our options. Now, when we talk about data plane recovery options with Federation, there's a couple of things here. One, they can be automatic, where there's a failure and our data plane is not really impacted. Or it could be manual, and that means if something happens, I have to go push a button, okay? So, automatic data plane recovery supports, let me change my colors here. Supports Tier 0 gateways, active locations, primary and secondary, plus a Tier 1 stretch with DR only, no services. Or we could do Tier 0 active locations primary, all locations primary, and Tier 1 is stretched with no services. So the key behind this automatic one, there's no services on our gateway. That's the key right there, okay? Then we could do manual recovery, and whether it's a Tier 0 or Tier 1 with services, like I'm throwing on the NAT or a gateway firewall or something like that. So let's look at these different ones, okay? Now, there's a lot of this stuff actually in the design guide. I personally haven't validated every single one of these because there's a bunch of different permutations here. So I basically went through a lot of the design guide and kind of condensed and simplified some of the stuff. But you can always look at the design guide if I don't cover an option here. But I think I got them all. So let's look at option 1. This is automatic data plane recovery. So let's talk about the automatic ones first. This will be active-active, so our tier 0s in each location is running active-active, and our locations is primary and secondary. We have no services here, okay? So one location of traffic is going to go in and out, and the other location will be a secondary. So here again, I'm showing you 3 locations. It could do it with 2 if you want to. Now you'll see I got my stretch tier 0 and I got my stretch tier 1 gateways. There's no services on there. I got a segment. I'm keeping the drawing really simple. I've got a segment with a bunch of VMs across these locations. Okay. So this is a 2-tier routing model. I just kept it really simple, right? Now, one of the things you'll notice, again, this is my physical router or top of rack switch or whatever the case may be, is we're going to advertise out this NSX segment, the blue network. We're going to advertise that out. It's going to get advertised out in all of the locations, and it will get advertised out at an equal cost. So which way do we come in? Well, the internet's going to see, hey, there's 3 ways for me to get to that blue network. I can go through location 1, 2, or 3, right? And you want to maybe control, well, what location it's coming in through. So in this example, we're going to advertise it out, these secondary locations, at a higher cost. So we may, again, we're using BGP here, eBGP, and we may do something like AS prepending or whatever to increase the cost of it. So in my picture here, you see NSX network with a plus sign, NSX network with a plus plus sign, right? And over here, NSX network. So what I'm saying here is location A is advertising out the blue network at a most efficient cost. Location 2 is advertising the blue network, the NSX blue network, at a higher cost. And location 3 is advertising the blue network at an even higher cost. So everybody from the internet is going to want to come in through location 1. That's kind of how we're going to control the traffic. So with this here, we got active-active, all locations, primary, secondary. Location 1 is my primary. So traffic, you'll see, is going to go in and out of location 1. No problems. Again, if the VMs here want to talk to each other, they can talk to each other. You know, east-west, that works, no problems. Let me change my colors. I'll pick a different one here. Again, as we can see, if somebody from the internet wants to talk to this machine, it comes in here and across like this, and then same thing back out. Now, what happens if there's a failure? Well, if location 3 dies, technically, who cares? Well, we do care about location 3. But, hey, location 1 and location 2 are still happy. Everybody's okay. Everybody's working. Data's still flowing. Obviously, location 3 is completely gone. The management plane over there is down. Control plane's down. It's completely gone, let's say, right? Now, what about... But data plane's still functioning out here on locations 1 and 2. But what about these VMs? Now, we're not talking about recovery here on the VMs. But when we talk about compute recovery, you'd probably be using something like Site Recovery Manager. I'll do a separate video on that, but that's not the point of this presentation, okay? So, great, everything still works just as before, right? We're coming in location 1, and we're going over to location 2 or whatever, everything's fine. Now, the problem comes into play here when we lose location 1, right? So location 1 now is gone. It's history, right? It says here, note asymmetric routing for location 3. So remember we advertised the blue network out all 3 locations. The best cost was from location 1, but location 1's not there. So it's gone. We can't use that. So the next best way to get there is using location 2, because we advertised it at a slightly higher cost than location 1. So location 1's the best way to get in, but hey, it's not there. We'll take the next best, which is location 2. Location 3 is still advertising it out, but at an even higher cost. We know we don't want that. It's too far for us, right? So traffic will flow in and out of location 2. No problems. East-west between locations 1 and 2. No problems. The problem runs in, again, with asymmetric routing because, again, now this guy over here, these guys see that their default gateway is no longer available, and they say, okay, we're going to use our own default gateway. Let's say it's the top of rack. So this is why location 3 is now sending it out that way. So this is where you get into asymmetric routing. Now you could, so technically speaking, it's automatic data plane recovery, but one of the issues is asymmetric routing, and it might be on location 3 you may have issues with. And to fix this, you can go into the NSX Global Manager, and there's a thing called the networking recovery, and you can say, I'm going to make this now my primary. So then it will force it to come out this way, right? So, but apart from that, data plane's technically functioning. How about if there's sometimes referred to as a split brain? Let's clear all this. In this example, I've lost communication to location 1. Something happened. We lose communication to location 1. Location 1 still is functioning. Data flows in and out of location 1. Everybody's happy still at location 1. The internet still sees the blue network via location 1. So traffic's going to come into the blue network via location 1. The problem comes into locations 2 and 3. Location 2 and 3 will say, oh, you know what? I can't see location 1 anymore. I'm going to use my default gateway and go out. And now when traffic comes back in, remember I said that we prefer to use location 1 for the blue network? Well, it's going to come out. Let's clear this. Let's say the traffic's coming out of here, hitting the internet, coming back this way, and then it's got to come across this way. Oops, we got a failure between the connection between these locations. So obviously, again, for north-south, location 2 and 3 is down. Okay? So in this type of situation, it's kind of called a split brain. You could, if you know location 1 is working perfectly fine and all that, you could potentially maybe do a site recovery manager to recover those workloads over here until you fix this break in the barrier type of thing. All right? So, so watch out for that. Again, here's another example, automatic. This is active, all locations primary now, whereas the one we just talked about, it was primary, secondary. Here's our picture. All locations are primary. Now, what we have here is asymmetric routing for location 2 and 3. So, yeah, sorry. So we're still advertising our blue network. So we're saying, hey, you know what? We want to advertise at a better cost from location 1 because we want the traffic to come in that way. We'll advertise it at a slightly higher cost of location 2 and a much higher cost for location 3 in this example. Now, this obviously introduces asymmetric routing because, again, if you got a VM over here, I'll use blue. Location 3 wants to talk to the outside world. It comes out. It's going to come across like this, back in this way, and across. Okay. Again, any physical firewalls, you know, at the top there, generally don't like that, and they'll drop it. Okay. So that may be an issue. Again, when you get into asymmetric routing, you got to ask yourself, is this going to be a problem for us, right? And this is one of, when we talk about all locations primary, it sounds really cool. Yeah, we got local egress, beautiful, but what about stuff coming in, right? You know, is asymmetric routing going to be an issue? Right here, we're advertising the blue network at different costs. We're forcing it to come in this way. But if you advertise them at equal cost, then you have asymmetric routing at all locations. Because I could go out this way, since it's equal cost, I might come back in this way, or that way, or whatever the case may be. Okay? But we're going to force everybody to come in through this way. Now, if you lose location 3, again, nothing's really different here. Location 1, no problems, it's okay. Location 2 still has asymmetric routing, again, just like it had before. So technically, nothing's changed for location 2. How about if you lose your location 1, where your primary location is, right? Sorry, location 1 now. Once you lose location 1, again, asymmetric routing for locations for location 3, right? So what happens here in this example, let me clear this. So we lost location 1. We're still all primary here. Now what we see here is location 2 is considered to be the best path to come back in. So now we're going to come in via location 2. So location 2 no longer has asymmetric routing issues. But location 3 still does, because it's going to go out 3 and then come back in through the 2. So you got to really ask yourself, if you want to go all locations primary, is this asymmetric routing going to be an issue? And by the way, I talked about, I mentioned we're going to advertise, I think I mentioned this already, we advertise the NSX network from each location by default at the same cost. You would have to go in manually to, let's say, locations 2 and 3 and add cost to those two different locations, like AS prepending or whatever the case may be. Okay, so that's something you manually got to do, and applies even for the other ones we talked about. Here again, split brain is what they kind of refer to this as, where we lose communication to location 1, and that's where all our traffic is coming in. We're saying, hey, internet, you want to talk to the blue network, come in through location 1, right? So location 1's happy. It's got no issues whatsoever. Locations 2 and 3 are still sending stuff out. They're still doing their all primary, so local egress. But this is where it breaks. It's coming out of each location, but it's got to come back in through here. And since we got a communication problem, it won't work. So this breaks your north-south for locations 2 and 3. Okay? So something you got to be aware of. But again, remember, before we were coming in this way and then going across like that, because we said this is the better cost to come in. Manual data plane recovery. So let's talk about active standby locations, primary and secondary. We're going to put services on our, now there's a bunch of different permutations here you could do. We're going to look at if somebody puts a service on their tier 0 gateway, okay? But they're not doing any services on their tier 1. So the tier 1 will be routing only, okay? So in this example, we've got some services on our tier 0 gateway that we're stretching across the 3 locations, whether it's a NAT service or firewall, whatever the case may be, whatever that service is. Now at that point, you're forcing the tier 0 to run active standby. End of story, okay? One thing before I mention, NAT, so we're clear here, NAT, if it's reflexive NAT, that's stateless NAT, then it doesn't have to go active standby. I'm not sure if that's supported in Federation, to be honest with you, just thought of that. So just a couple things. Whenever you put in services on your tier 0, at that point, it's active standby. Now notice what's different in this picture. We got our blue network, again, on our tier 1, and we're advertising it out only at a location 1, because everything's active standby now, and we have services on that tier 0, so we have our primary and we have our secondary location. So everything's going to come in, again, through, I don't like that color. Everything's going to come in through location 1 and then go across down to the other locations. Now when we want to get out of our locations, we go from our tier 1 to our tier 0, then we have to go across to the location 1 and then out. Okay? So let's throw a failure in here. Again, location 3 died. Technically speaking, no big deal. Everything still works. Okay? Except for location 3. Again, you could do, if you got workloads here, you could use SRM to do recovery if you've got SRM running, but that's above and beyond what we're talking about. All right? But everything works fine. What happens if this happens? What happens if location 1 dies? Location 1 is dead. We told the internet to come in through location 1 for the blue network. All right? Because again, this one here, this gateway is the only one that's advertising the blue network. So it says north-south for locations 2 and 3 is down. We now need to manually go in and promote either location 2 or location 3 as primary. Now, there's a couple ways you could do that. There's a thing called the network recovery process. So if you had the global manager cluster, let's say the global manager active cluster was running at location 1, and you had the standby on location 2, you would have to go into, let's say this location 1's totally gone, you'd have to promote the standby. It takes a few minutes to do that. Once you promote it, then it can actually detect and say, hey, you know what, location 1's gone. Let's go into the, do you want to run the network recovery process? So there's a little process that you click on and then it'll show it to you, right? And then you say, okay, I want to promote location 2 now to my primary. So right now, there's an outage here, okay? in this type of configuration. Now, you'll notice east-west is still working fine. Okay, my north-south is not working because we're going to come out here and we've got to go across there. Oops, we're done. Like if I go back to the previous picture, we go up this way, we go out this location, tier 0 at location 1, but it's dead, so we can't get out there. Okay, so there is an outage here, and you need to manually go in and press a button. Okay. How about a split brain situation? In a split brain situation with the same configuration, active, standby, primary, secondaries, and again, services running on our tier 0 here. Location 1 is perfectly fine. Everything's working on location 1. It's location 2 and 3 that's going to be suffering at this point, right? We still have east-west working between locations 2 and 3, but east-west is not working from location 1 to 2 or location 1 to 3 or vice versa. So east-west within location 1 is fine. East-west between locations 1 and 2 won't work, or 1 and 3 won't work. But east-west between 2 and 3 in this example does work. Again, when we want to go north from location 1 or 2, we go up to our tier 0. We need to go across to this guy, which is the active, and it's obviously it's busted, so it won't work. I think this is the last one. Manual data recovery, active, standby, locations, primary, secondary, no services on tier 0. We're going to put services on tier 1 now. So the one we just talked about, we had services on tier 0, and we had no services on tier 1. We're going to flip that around. So again, active. Now we're going active, because now there's no services on tier 0. We can go active. And again, we're doing primary, secondary in this case. Again, in this example, the tier 0 will advertise out the blue networks. So my NSX networks that I'm stretching, it will advertise them out all 3 locations. And it's up to you now to say, okay, which location do we want to come in? We want it to come in on location 1. So therefore, we'll go and advertise it out at a higher cost from locations 2 and 3. So the internet says, hey, I'm only using location 1 to go into the blue network, not 2 and 3. Okay? So again, when we look here, since we're putting services on our tier 1 and everybody's sitting behind the tier 1, all that traffic must go through that single tier 1. And better yet, it's got to go through a single edge node on that location, which is ouch. Can you imagine if you had hundreds of machines here going through a single edge node? Anyways, unless it's like a physical one, right? So this is how it works. Now, obviously, we kill location 3. It doesn't impact locations 1 and 2. Everybody's still happy, okay? Except for location 3. Again, you can recover the workloads using Site Recovery Manager. I'll do a video on that some other day. But what happens if we lose our primary location here? It says, note, north-south for locations 2 and 3 is down. You now need to promote location 1 or location 2 using network recovery. Sorry, you can promote this. Okay, so why am I calling out location 2? So basically what's happening here is, first of all, east-west in location 2 and 3 are still functioning. Location 1 is totally gone. It's toast. Again, if you had your global manager active cluster run on location 1, your standby, let's say it was on location 2, you'd need to promote that. Okay. Once you promoted it, you now need to go in and promote. In this example, I'm going to say location 2. I need to promote it to the primary. Why? Because I'm advertising out the NSX network at a better cost than location 3. So I want to make this my primary now. So again, I could do that with the network recovery, or you can actually just manually go in and do it. I'll do videos on it, but I'm still working on my lab environment. Ran into a bit of a hiccup on that. Anyways, I'll talk about that when I get it done. So again, north-south for 2 and 3 is down. You'll need to promote. So we have an outage here, okay, and an outage in and out. Oh, and by the way, again, since this network, the blue network or whatever our networks that we're advertising out, is at a better cost on location 2, location 2 still sends it out this way, and it says, oh, I need to send it across here, because this is where the active tier 1 is, right? It's on location 1. So obviously the active tier 1 is gone, So at that point, we're unable to, we don't have any north-south. So we got to go in location 1, promote it to primary. So the active tier 1 now runs over here. Same kind of thing with the with the split brain. If we lose communication, so we basically have somehow we've lost communication with location 1. And again, it's active, primary, secondaries. So again, location 1 is perfectly happy. Everything's working north-south. Location 2 and 3 are the one that's suffering. Since we lost communication between them, east to west for location 2 and 3 still works. So these VMs on 2 and 3 can still talk to each other. But if they try to talk to any VMs on location 1 or get out, they're toast because we lost the connection between them, okay? So that's pretty much it. So in summary, which one is better? It's a really good question. They both have their pluses and minuses, okay? So when we talk about NSX Multi-site, a large set of the networking security features are available. You know, IDS, IPS, malware, all those things are available. It does have the smallest footprint. It does have a simple DR solution. Again, it says with strict requirements on Fabric and vCenter, so like stretched vSphere clusters, that we talked about that, okay? So I could use vSphere high availability to fail over for me. What are the cons? Well, I'm limited to scale to one NSX management cluster. So how many tier 1 gateways can I have? How many segments? That's usually a fairly big number, but that may be okay for you, but maybe not. You do need that large MTU between the sites. That might be a showstopper. So again, VMware recommends minimum 1700. You go more, it's even better. Management planes centralized in one location. I don't know if I worded that properly. Remember in multi-site, I could actually have my managers go across sites if I had stretched cluster or less than 10 milliseconds, just like in Federation. Same kind of thing there, but I think it's referred to, we just have a single management cluster type of thing. So that might impact other stuff, any kind of regulations that you may have to adhere to. Complex DR, if some strict requirements are not met. Again, we looked at some of the DR solutions. Some of it could be automatic. If you don't have stretched cluster, vSphere cluster, then it could be a little bit more. Up to 150 milliseconds between sites, that's a con, because the reason why I'm using that as a con, because I can do 500 on Federation. No local egress support, okay? Doesn't mean it doesn't work, but it's not supported. Again, I'm just going by the documentation. Federation, the pros, no large MTU required between the sites. Highly recommended, though, to have it, because you don't want to be doing fragmentation. Distributed management plane, that's the nice thing about it, because you've got multiple management and control planes. You have management and control plane at each site. So if a site goes down, it doesn't impact control plane at the other sites, okay? Simplified DR solution with no Fabric or vCenter requirements. Again, I don't need vSphere's high availability. Again, I mentioned up to 500 milliseconds. The cons here is limited set of network and security features. So both multi-site and Federation, you have to look at the supported features, especially with partners, okay? You want to make sure that the solutions are supported for whichever one you decide you're going to use. But Federation has a longer list of what is not supported. And obviously, one of the things we talked about, large footprint. Yeah, you know, you got local managers, you got the standby global manager cluster, the active global manager cluster and stuff. That's it, folks. Thanks for watching. Which one do you think is better? Leave comments down below, all right? By the way, if you like this, hit that thumbs up. If you haven't subscribed to the channel as of yet, hey, do me a favor. Please subscribe to the channel. Does me a big favor when you do that. I'm trying to hit the 1,000 mark so I can get monetized from YouTube, so I would really appreciate it. It's free. Just click on the button. Leave comments down below if there's stuff that you want to see or do. I've had a lot of feedback on various things people want to see, and I haven't forgotten. I know some stuff on Avi, load balancer, and all that stuff. I'm working on all that, but I want to get my Federation lab up and going. I got some interesting stuff I want to show you. But leave comments down below. Let me know if there's something you want to see me do, and have a great day. Bye now.